Hello guys, welcome to Unit 4, Lesson 4, Unit Rates with Ratios of Fractions. Okay, so there's a lot of good information in your lesson, but the one thing that I really wanted to highlight first is, we haven't really talked about this term yet, multiplicative inverse. Multiplicative inverse. So if you take the inverse of something, you're taking the opposite of something. Okay? And so multiplicative, you can probably see that first part, right? Multiply. A value when multiplied by a number gives a product of 1. So if I ask for what is the multiplicative inverse of 3/5, it would be 5/3, because when I multiply them together, I get 15 over 15, which reduces to 1 over 1, which is equal to 1. Okay? So we're going to use a little bit of that today when we're trying to find our unit rates. Okay? So our first example here, just fractions, right? Remember, we use the same change flip. Some people say keep change flip. However you remember it, doesn't matter to me, as long as you do it before you divide. So I'm going to keep my first fraction the same. I'm going to change my symbol to multiplication, and then I am going to take the reciprocal of the second fraction. Now that I have done that, I can go ahead and multiply straight across. None of my numerators have anything in common with my denominators, so I can't reduce right now, which also is a huge hint. If I can't reduce right now, I'm not going to be able to reduce later either. So 1 times 7 is 7, 2 times 12 is 24, giving me a final answer of 7/24. We actually use that multiplicative inverse a lot more than we think we do. We just don't refer to it like that very often. So number 2, Rubio decides he is going to walk to his friend's house, which is 1 mile away. He can walk at a pace of 2/3 miles in 16 minutes. How long will it take him? Okay, so first thing we're going to do, let's see, his friend lives 1 mile away, and then I know that he can walk 2/3 miles in 16 minutes. Okay, I'm actually, in order to help us visualize this, I'm going to draw a picture. So let's just say that this thing right here, maybe this is like the road, okay? And here is, there's Rubio's house, okay? And his friend maybe has this pink house, something like that, okay? Doesn't have to be super detailed. Now there's a couple things that we know. We know that this whole distance is equal to 1 mile, and he can walk 2/3 of it in 16 minutes. So I'm going to do a couple things. One, I'm going to do my best to break this up into 3 somewhat equal pieces. We're going to pretend like they are actual thirds, right? Here's 1/3, here's 1/3, and here's 1/3. Well, I know that he can go 2/3, right, in 16 minutes. Well, if he can go that whole distance in 16 minutes, how far does that mean he can go, how long will it take him to go half of that? Right? Well, half of 16 is 8. So what that tells me is that he could go this last 1/3 mile in 8 minutes, right? Because if he goes this distance in 8 minutes, here's this distance in 8 minutes, that gives us our 16. Well, that means this last one would also be 8 minutes, making our total be 24 minutes. And we could say per 1 mile. Okay? So that's his unit rate, but it also tells us how long is it going to take him. It's going to take him 24 minutes. This last one, I felt like this one was kind of tricky This is number 5 from your quick check, okay? Number 5 from your quick check. So I didn't write the whole thing down, mostly because I got lazy, sorry. But let me go ahead and read it out loud to you. It says, Iris is asked to sweep the gymnasium floor after a basketball game. That sentence doesn't really matter in the big scheme of things. This requires her to push a sweeper from one end of the gym to the other and repeating the pattern until she has covered the entire floor. She completes 2/3 of the floor in 1/3 of an hour. At this rate, how long will it take her to complete the entire floor? So once again, I'm going to draw a picture to kind of give us an idea of like, what do we need to do? I don't like that bright green. I'm going to switch over to my darker green. So let's just say that here's the floor, right? Here's the gym floor. She can complete, excuse me, okay? So, and I've broken it up into thirds. The reason I did that, right, is because she completed 2/3 of the floor in 1/3 of an hour. Well, so it's a very similar problem to the last problem we just did, but thirds are just kind of funky, right? So she was able to complete 1/3, 2/3. So she was able to complete 2/3 in 1/3 of an hour. Okay? So right here, though, this last third, we're like, okay, well, how long does it take her to complete that? Well, notice this is half of this amount, right? So really, what I need to do is I need to say I need to take 1/3, and I either need to find half of that third, or I need to divide it by 2, right? I can divide this 1/3 hour by 2, and that will tell me how long it took her to, what was it, sweeping? How long it took her to sweep this final section, and then we can, it said, how long will it take her to finish, right? So we want to know, like, what is this amount of time that takes her? So if I'm doing 1/3 divided by 2, well, I can turn this into a fraction because I need to do my same change flip. I'm going to leave my first fraction the same. I'm going to change my symbol to multiplication, and then I'm going to flip my second fraction or take the reciprocal. Okay, so notice what I did. I said I could either take 1/3 and divide it by 2, or I said I could take half of 1/3. Of means multiply. So that's another way to show that like these are equivalent. They're the same thing. So to do that, we could take 1/3 times 1/2, multiply straight across, and that gives us 1/6 of an hour. Okay? You could take it even further. So like this is your final answer, and I'm sorry, I wrote this wrong. How long will it take her to finish? That would be this. But your final question actually is, how long will it take her to complete the entire floor? So if this took 1/3 hour, and this takes 1/6 hour, we need to combine those. Okay? So we need to combine them, meaning we're going to add them. So we have 1/3 plus 1/6. Well, in order to add fractions, we have to have a common denominator. So I can change my 3 into 6's really easily by multiplying by 2. Whatever I do to my denominator, I have to do to my numerator. So 1 times 2 is 2. 3 times 2 is 6. Plus 1/6. Now that I have a common denominator, I can add my numerators, giving me 3/6. But what is 3/6 reduced to? Look at all this math we're doing, combining all our lessons. Well, 3 and 6 can both be reduced by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Meaning that it would take her half an hour. Okay? Another way you could have thought about it, but not that the problem wasn't set up this way, but you could think, okay, if I divide an hour up into 3 equal sections, that's like 20 minutes each, right? 20 plus 20 plus 20 gives me 60 minutes, or 1 full hour. So 1/3 of an hour is 20 minutes. 1/6 of an hour would be 10 minutes, right? If I take those 60 minutes and divide them into 6 groups, that's 10 minutes. Well, 20 minutes plus 10 minutes gives me 30 minutes, which, ta-da, is half an hour. Okay, so I hope that helps. We're putting those rates and ratios and everything into practice, but as always, if you need more, just let me know.